Hi folks, Mr. Long here. Today we're going to talk about oblique asymptotes. And here's what I want you to notice. I'm going to take a look at Desmos, and I've got, as you can see, an equation in the top left of 2x squared plus 3x minus 5 divided by x plus 2. And you can see that there's the graph, and what we're really showing here is local behavior, right? So we're showing the dotted green line is the asymptote, and the red line is the curve, is the function. So if we look at this, so if we start to zoom, so if I zoom in, right, you can see very clearly that the y-intercept of this, of the asymptote, is -1. But what I want you to notice is, as I zoom out, what happens to the asymptote and the curve. So if you notice, really, it looks like the asymptote and the curve are totally overlapped. And if I really zoom out, the graph actually looks like a just a straight line. It looks like a vertical line and then a diagonal line, a sloped line. Okay, let's go back now to there's where we're zoomed in on it, and it looks something like that, right? So what I want you to notice, so I've got a picture of this on the next sheet that I'm going to go to on the Jamboard. So look at this diagram. Okay, and here's what I want you to notice as we look at this diagram. So what I want you to think about is, here's the oblique asymptote here in green, and I'm looking at the distance between the curve, the function, which is in red, and the asymptote, which is in green. What's true about the distance between the asymptote and the curve as we go further and further and further to the right? What happens? So the distance from r of x, that's the red curve, to the oblique asymptote, the straight line that's dotted green, decreases as x approaches positive or negative infinity. And in fact, it gets so close that they seem to overlap, right? Because the distance approaches 0. Now, it never actually gets to 0. Doesn't that sound like a limit? We're getting closer and closer, but we don't quite get there. So that's actually the definition of an asymptote, is when a function approaches a straight line or some other type of function. For our purposes, a straight line, it gets closer and closer and closer, but never quite touches it. Okay, so that distance between, you can see here, the distance between the asymptote, the green asymptote, and the red function is approaching 0. And that's what the definition of an asymptote. So basically, as x gets really, really big, the asymptote will just overlap the function. Okay, and we saw that. So let's assume that we've got this function over here, and we want to figure out what is the y-intercept of that asymptote. Okay, we're going to do it with algebra. So just first, let's figure out what the oblique asymptote is. So I've already stated here that it's 2x. Well, why is it 2x? Well, if x was approaching infinity, the 5 is insignificant compared to 2x squared. The -3x is insignificant compared to 2x squared. The 2 is insignificant compared to x. Well, what are we left with globally? Globally, we're left with 2x squared divided by x, which is 2 of x times x, divided by 2 times x divided by x. So if I look at those things, and it looks like the oblique asymptote is at 2x globally. Remember, that's n behavior. Okay, that's n behavior. So I'm going to go back and show you that it is 2x in terms of the n behavior. So, for example, and I'm just going to turn those off. Oh, there's a straight line 2x minus 1. Now I'm just going to type in the straight line y equals 2x. Okay, so you can see locally, right, if I zoom out, or zoom in rather, you can see very clearly that those are separate lines. So that the purple line is 2x and the green line is 2x minus 1. Okay, so locally, very clearly, they're different graphs. But what if I zoom out? What if I zoom out, way out? And this is only, look at that. So now I'm zooming out. What do you notice? 2x minus 1 and 2x. What do they look like? They look exactly the same, right? Because I'm dealing with scales that are much different. So if you look at the x-axis, it goes 0, then 1,000, then 2,000. The y-axis is going up by 2,000s. So globally, 2x minus 1 and 2x are the same thing. But locally, they're not. Okay, locally they're not. And this is how this is what relates to oblique asymptotes. Okay, so let's go back to this. So we know that the global behavior of the oblique asymptote for this function is 2x. But locally, there is a y-intercept. Globally, it's insignificant. But locally, it's quite significant. Okay, so let's look at how do we get this? Well, what we just said, that as x approaches infinity, r of x equals the oblique asymptote, right? They overlap, basically, okay, as x approaches infinity. So here's what we're going to do. We're going to sub in 1,000 to both. So I know that r of x is 2x squared minus 3x plus 5 divided by x plus 2. And now that equals the oblique asymptote, 2x plus b. Okay, I know that. So what I'm going to do is sub in x equals 1,000. And I'm sufficiently far to the right that basically this function here should overlap this function here, right? So I'm going to do that. I'm going to sub in 1,000. So when I sub in 1,000, I'm just going to write the numbers down. So if I subbed in 1,000 here, well, the right side's really easy. 2 times by 1,000 is 2,000. So that's going to be 2,000 plus b. And on the left side, it works out to 1999 rounded to the nearest one. Okay, well, it's 1998.997, I think. So if we look at that, so that means this right here is worth 1,999 if x is 1,000. And over here, it's 2,000 plus b. Well, what is the value of b to make that equation true? Well, b will equal -1. Okay, b equals -1. So therefore, the oblique asymptote locally is y equals 2x minus 1. Okay, and let's double check that that's true, because I've graphed everything here on Desmos. So look at this. Is that in fact accurate? Look at that. -1, -2, -3, -4, -5. The y-intercept is right there, -1. Okay, so this oblique asymptote has a y-intercept of -1. Okay. All right, so just to go back over that then, the easy way to do this is just to say, whoops, go back here. Oh, I see. I just have to zoom out. There we go. So the easy way to do this is just to say that if I sub in 1,000, okay, if I sub in 1,000, then the rational function has to pretty much overlap with the oblique asymptote, right? I'm sufficiently far out to the right towards positive infinity that the oblique asymptote is going to overlap the rational function. So the way I do that is set the rational function equal to the oblique asymptote, subbing in something very far to the right. And so I did it. 1999 for that, 1,999. 2 times 1,000 is 2,000 plus b. So by the way, I subbed in For x, I subbed in 1,000 and I got that result. And then I solve for b. b is going to be 1999 minus 2,000. So the oblique asymptote locally is 2x minus 1. So that's how you get the y-intercept of an oblique asymptote. Okay, hopefully that helped.